Hello, teachers. Let's pick up where we left off in section 11.1. We were defining quite a bit of geometry terms. Now we've got some problems to do. So we're supposed to find the measure of arc AB associated with the central angle AOB. So let's find that. So the measure of arc AB, so I would think that the arc AB would be right here highlighted. And that is the measure of angle AOB. There we go. Now, we don't know that angle right there. How could we find that angle? Well, notice that we have a straight line right here, right? And we know that this part of the angle is 60 degrees. So that must mean that other part is 120 degrees, which means this arc is 120 degrees. Again, how did I get the 120? I said 180 degrees minus the 60 degrees that's already labeled for us must mean that this is 120 degrees. Okay? So typed up, there you go. There's your 120 degrees. Let's look at the next question. Find the measure of arc AF associated with the central angle AOF. I suggest you pause it, go ahead and find this on your own, and then we'll come back and talk about it. How did it go? Did you figure it out? So we have arc AF that I highlighted in green associated with the central angle AOF, which is 60 degrees. You know what? So that arc AF, so we could use notation like this, arc AF would equal to 60 degrees. And I should say the measure of arc AF is 60 degrees. And let's look at the typed up version. There it is. The measure of AF, or the measure of angle AOF, is 60 degrees. Let's look at another problem. Okay, so, didn't change. There we go. Find the measure of arc BC. So let's find BC. How about you pause it real quick again and figure that out and come back. Now, I feel like you're kind of missing a little bit of information to pull this problem off. We know that we've got 60 degrees and also we have 120 degrees here because we had a straight angle of 120 degrees. On the other hand, they haven't told you this yet. It's coming up in a future section, but it feels like they really need you to know that vertical angles, angles across from each other made by intersecting lines, have the same angle. So that is 60 degrees. And I don't feel like you could figure that out without knowing that. Maybe I'm just not seeing it. so we're going to assume you know that. By the time you take the test, you will know that. But right now, that's a bit of an assumption. But that means that arc would also be 60 degrees. Remember, the angle and the arc have the same measure. All right, next example. Find the measure of arc FDC associated with the central angle FOC. Okay, why don't you pause it and figure that out. How'd it go for you? Did you get it figured out? So notice in pink is the measure of the arc that we're trying to find. That's associated with the angle FOC that I highlighted in purple. Now, remember, we found out previously that this angle was 120 degrees, and we discussed why that angle is 60 degrees, although that wasn't official yet. Well, if I knew that was 60, then I could straight angle here. That's my straight line, right? That must be 120 degrees. Or again, you could use the idea that these are vertical angles, and that's that idea we really haven't officially learned yet. But you know this. You know this back from geometry. So this is 120 degrees, which means the measure of arc FDC is equal to 120 degrees. If I look up the typed up version, there it is. Now they did 180 minus the 60 that we had already, which we talked about where that 60 came from. That's the way we found it as well. Next, let's talk about perpendicular lines. By the way, you may hear it storming here. It is storming. So if you hear loud thunder and raining, there it is. But I got to keep going with the video. So here we go. So perpendicular lines, you know what that means. They meet at a 90-degree angle. Notice the notation that we have right here. Whenever you see a little box drawn into an angle, that is telling you that this is a 90-degree angle where they meet, or a right angle. We know that's called a right angle as well. Notice the notation. This would be read, M is perpendicular to N. So anytime you see that upside down T, That's exactly what we're talking about. And you see line M is here in purple, and line N, let's do that one in green, and those are perpendicular to each other. You could also say AB is perpendicular to BC. Again, you see AB here, BC along the green line there. Those are perpendicular. Another way you could say it is BA is perpendicular to BC. Both of those are correct. Now here we have a definition of a line perpendicular to a plane. More like a picture is a line that is perpendicular to every line in the plane through its intersection with the plane. Now what this is saying, look at the blue line, you see that, BA? So we could say BA is perpendicular to plane alpha, okay? But notice that that line, the BA, the blue line, is perpendicular to line K, to line L, to line M, to every single line that shows up in that plane. And that's what they're trying to say. When you have a line perpendicular to a plane, it's really a line that's perpendicular to every single line in the plane. What about perpendicular planes? If P is any point on AD, okay, so where is AD? So here is the line AD, and P, you see P right there. P is any point on AD. Q in plane alpha, okay, so you see Q, you see plane alpha. If I draw it out, that is plane alpha, and here is the point Q. And S in plane beta, so let me change colors. So S is in plane beta, so here is S, and plane beta is this guy right here, and it would also be highlighted in purple in the middle there, okay? So that PQ is perpendicular to AD, so you see PQ, okay, I would denote that one in green since it's in plane alpha, is perpendicular to AD. And remember, AD is the vertical one. Okay, so PQ is perpendicular to AD, and PS is perpendicular to AD. So over here, this is PS. It's also perpendicular to AD. Then the angle QPS is a lot to take in. So here's QPS. You can see me drawing it with my line. There's angle QPS is also a right angle. Since angle QPS, the one we were talking about, measures 90 degrees, the planes are perpendicular. So basically, you got a plane connected to another plane. If they make a 90-degree angle, you see highlighted there and there. That means they are perpendicular planes. Probably easier to understand than all that diagramming, don't you think? And then the last slide I have for you today, dihedral angles. A dihedral angle is formed by the union of two half planes. Remember, half plane really is literally half a plane, and the common line defining the half planes. Okay, so a dihedral angle is measured by any of the associated planar angles, such angle OPD, where PO is perpendicular to AC and PD is perpendicular to AC. So basically what they're trying to say here is to measure this dihedral angle, you just need to know the angle here or here. If you know those angles, then you know the measure of your dihedral angle. And again, a dihedral angle is just an angle between two half planes. All right, that wraps up my conversation for section 11-1. If you struggle with the homework or you need more lecture, you feel like there's some muddy points, please let me know, and I will definitely fill in the blanks. I hope you have a wonderful day, and come on back for section 11-2.